Okay, we're going to look at Lesson 116. Lesson 116 is talking about the region of interest. And what the region of interest is as we've been graphing these equations of higher degrees, we've noticed that as you get into very large negative or very large positive numbers, that the graph just kind of continues smoothly, either negatively or positively. But there's a region in here that all of the turning points occur and all the flex points occur. And that's what we're going to learn, is how to find out what that region of interest would be. The way that we do it is by looking at the normalized polynomial equation. Well, what is a normalized polynomial equation? All that is if you take an equation such as 3x to the fourth minus 11x cubed plus 9x squared plus 13x minus 10 equals 0. Well, a normalized polynomial equation is simply an equation in which the term with the highest degree has a lead coefficient of 1. So in this case, because this is in descending order already, the x to the fourth is the degree with the highest degree term. So we want to make this a 1, a lead coefficient of 1. So we just divide every single term by 3 on both sides of the equation, but because it's equal to 0, that's still going to be 0. And we get x to the fourth minus 11 thirds x cubed plus, I'm going to leave this as 9 thirds x squared plus 13x over 3 minus 10 over 3 equals 0. We look at this normalized polynomial equation and we find the largest absolute value term in this equation. So we have 11 thirds, 9 thirds, 13 thirds, and 10 thirds. Obviously, the largest one is 13 thirds. The region of interest is going to occur within the largest term plus 1. So, and actually I'm going to do 3 over 3. So the region of interest, all of those twists and turns are going to occur within 17 thirds or 5 and 2 thirds. So you can have, when you're graphing it, you would essentially have a circle whose radius is 17 thirds, and all of the twists and turns, all of the roots, because everywhere that it's going to cross the x-axis, are going to occur within this circle. And that is called the region of interest. The other equation that they just give as an example to see a normalized polynomial equation, they had 3x to the fourth plus 2x cubed minus 2x minus 4 is equal to 0. So to normalize this polynomial equation, we just divide everything by 3. We get x to the fourth plus 2 thirds x cubed minus 2 thirds x minus 4 thirds is equal to 0. Which coefficient has the largest absolute value? Well, it would be 4 thirds. So plus 1, or 3 thirds in this case also, 7 thirds. So the region of interest is going to be within 7 thirds. So if we had that graphed, all of the twists and turns are going to occur between 7 thirds and negative 7 thirds. So within that region, all of the roots of the equation are going to be there, and all the turning points and all the flex points. All right, let's look at the examples. Example 116.1. It says to graph y equals x cubed minus 3x squared plus x plus 1. All right, so let's take a look at what we've learned in previous lessons. One, we know that this is a cubic function. Cubic function is going to have 2 turning points. We know that if we were to graph this, that for very large negative numbers, if you have a negative and you cube it, this is going to be negative, so that dominant term is going to, for very large negative numbers, be negative. For very large positive numbers, that's going to be positive. So we have an idea of the ends of it. Now we want to kind of get an idea of the region of interest here. So how do we find the region of interest? Well, we normalize the equation. This one already has a lead coefficient of 1, so we don't have to divide everything. So it's already normalized. So we look at the coefficient with the largest absolute value, and that would be 3. So 3 plus 1, 4. So all of the twisting and turning points are going to occur between 4 and negative 4. So since we know that, now we can use synthetic division to find some points in there. Because remember, when you use the synthetic division, the remainder tells you what the y point would be. So let's see, they picked some points here. I'll try and fit it all in over here. They picked negative 2, negative 1, 1, so we'll start with the negative 2, and I'll try and write small enough. 3, 1, and 1. We're not missing any terms, so we don't have to put any zeros in. Okay, 1, a negative 2, a negative 5. We multiply, we add, we multiply, we add. So we see that we have the point. Let's see where I'm going to write these points. I'll write them over here. We have the point negative 2, negative 21. Don't know if you can see that. Let me see. Maybe. Okay. Let's try another point. Let's do negative 1. So bring down the 1, multiply. This times this, negative 1. We add. We multiply, add, multiply, and add. So we see we have the point negative 1, negative 4. Okay. Let's do the point 1. 1, negative 2, negative 2, negative 1, negative 1, 0. Oh, we found a 0. So we do know that it is going to cross at 1, 0. So at 1, 0, we have a point here. So we'll go ahead and just graph that one right away. All right, let's look at some more. Let's do 2. Oh, yeah, multiply, add, multiply, add, multiply, and we get negative 1. So we have the point 2, negative 1. That's a pretty good point. I'm going to graph that one as well. 2, negative 1. Okay. All right, let's try 3. 3, 0, 0, 1, 3, 4. I have a point 3, 4. That's pretty good too. 3, 4, so we'll graph that. We're kind of starting to see what's going on here. I guess my arrow shouldn't be way up there though, should it? We know that it's going to continue this way here. Okay. And we'll try the point 4. 4, 1, 4, 5, 20, and 21. Okay, so we're seeing with 4, it's all the way up at 21, so that's gonna it's going to increase pretty quickly there from that point. All right. So now let's take some negative points. Did we do some negative? Oh yeah, we have -1, -4. So we have this point here. We have -2, -21. So that's way down here. So this is already way down here somewhere, right? So we have those points. So we have a pretty good idea of this graph now. We can see it goes from here. Oh, what about 0? 0 is always a good point. So if we put 0 in, we would have 0. These are all zeros. 0, 1. That's a great first one to do. I don't know why I didn't do that. So now we could see that this graph is going to look like that. And that's it for that one. Let's look at example 116.2. I'm going to remember to do that 0 first. Okay, 116.2, it says to graph y equals x cubed plus 4x squared plus x minus 6. All right, so let's see, we'll do our region of interest first. Our region of interest, this is already normalized because we have 1 as a lead coefficient. This is the greatest absolute value, so the region of interest is going to be this plus 1, so the region of interest is going to be between -7 and 7. We know from this dominant term that for very large negative numbers, it's going to be negative. For very large positive numbers, it's going to be positive. One point that I know that I'm going to do first this time is 0, -6. So that's 1 point we have already. And then we can just pick some points between -7 and 7 to find out what's going to happen with all of those twists and turns in there. We will do the same ones that they did. They did -4 was the first one that they did. And synthetic division, take the coefficients for each one of these. Again, there are no missing terms as far as written in descending order, so we don't have to fill in any zeros. Here we bring this down and we multiply, add, multiply, add, multiply. So we get -4, -10. Yeah. Okay. Let's do -2. And multiply, and add, and multiply, and add, and multiply. And we get a 0. Okay, so we found one place where it's also going to be crossing. I'm going to put that one up here just because that's one of the zeros. Okay, let's try 2. Bring down, multiply, add, multiply, add, multiply. And oops, yep. And we get 220. Yeah, those are kind of off the chart a little bit, but good to know where they're at. Let's do 4. 4, 16. 4. Oh, this is going to be huge. Actually, I didn't even what did I do around here? Oh, I multiplied instead of adding. Yeah. Okay, and so we get 126, a very large number. I'll write it even though I'm not going to graph it. All right. So on our graph so far, what do we have in this region of interest? We just know that we have 0, -6. We know that we have -2, 0. We know that we have -4, -10. So that's going to be down here. We have 220, that's way up there. And 4, 126, that's way up there somewhere. So this is kind of what we have so far. Doesn't help us a whole lot. So let's pick a couple more points and see where they're at between -4 and -2. So we'll do -3. Again, let's see, 1, 4, 1, -6. Bring down. I guess I need to say this out loud and add. There we go. We found another 0. So 3, 0. All right. Now we know we have, because of this, we know that we have 2 turning points. So obviously it must turn somewhere in here. So this is going to turn somewhere there. This is going to come up. We're going to turn somewhere. This is going to come down. But then we need to come back up. So let's try, they did -1. I don't even think -1's necessary because we know it's coming down to 0. Let's do 1. Multiply, add, multiply, add, multiply. Oh, and another 0. So we know that at 1, 0, we have this. And then we knew that at 2, we had 20, so we just know that this is going to come up and go way up from there. We do need to figure out what's happening here to just give us a better idea of this graph, this part of the graph here, because obviously it can't go straight across. It must come up somewhere. So we'll do -2.5. So -2.5, we would get 1.5. And then multiply.